Good day, my name is Marian Digo, and my given topic is redundancy building resilience into the network. And the first is the redundant links. Implement multiple network links between critical devices, ensuring that data can flow even if one link fails. This approach provides failover capability, minimizing services. And there are some examples of redundant links. First is the in a website, a link that connects to another link that goes to the same page. This can happen when a website uses images that are also hyperlinks, or when HTML tables are used for layout. And the next is a network. In a network, a link between switches that's prepared in a case that main link fails. And the last is a network computer. In a computer network, two links that operate in an active backup setting. If one link fails, the other can take over. The redundant links can be frustrating for users, especially those who use keyboard or screen reader. For example, a screen reader user may hear the same hyperlink announced twice. And the second is the redundant power supplies. Ensure that ensure that data ensure that critical network devices have redundant power supplies. This prevents service outages due to the above failures, ensuring interrupted network operations. Ang redundant power supplies mao ang device nga ga-allow og single piece sa equipment para maka-operate ang multiple supplies. Ug naay mga example ang redundant power supply. Una kay ang Cisco. Cisco network equipment uses dual redundant power supplies, which are modular and allow you to change out the power supplies. And the next is the Advantage Energy Call X power supplies, designed with the redundancy features, including an internal or configuration that prevents damage during a redundancy shutdown. And the next is the network switches. Typically support hot swapping, which means you can replace a faulty power supply without taking the device offline. The redundant power supplies are commonly used in a server's blade, chassis, and large network equipment. They are used in situations where uptime is critical, such as in a hospital healthcare facilities, to ensure a continuous power supply for essential medical service. And the next is redundant routers and switches. Deploy redundant routers and switches, providing backup pathways for data traffic. This ensures uninterrupted network connectivity even in case of device failures. Og there are examples of routers and switches. First is the duplicate system. With the same model software and connections can be used in any key network locations. Stackable switches are an easy way to implement this, and that is the identical system. Redundant links and switches. In a LAN spanning tree protocol, or STP or rapid STP, can prevent problem caused by frames looping through redundant paths. Ang STP or spanning tree protocols kay mao ang network nga mag-prevent sa loops o broadcast storm sa internet. Tapos it does this by creating a logical topology that disables links that are not part of the spanning tree, leaving a single active path between any two network devices. And a virtual gateway. A virtual gateway can be created between two multi-layer switches to provide a default gateway for a computer. If one switch fails, the other can take over. Protocols such as HRP, Hot Sunday Routing Protocol, VRRP or Virtual Router Redundancy Protocol, or LGP Gateway Load Balancing Protocol can be used to create a virtual gateway. Mao na ang maka-create og mga virtual gateway. And the last is redundant WAN links or wide area network. In a WAN with a remote branch's office, each branch can have two WAN links connected in one network. An IP routing protocol can learn routes over both links and add the best route to the routing table. If one link fails, the routing protocol can add the alternate route. And that is the example of the redundant routers and switches. And the next is reliability, ensuring consistent network performance. First is the network monitoring. Implement the robust network monitoring tools to track network performance. Identify potential issues early and proactively address problems before they impact users. So, sila ang mga ga-monitor mo ni ang mga ga-monitor sa network para makuan din ang mga problema nga before makuan sa mga users. Ay siya maka-impact sa mga users na mga network nga ga-monitor. And the next is network security. Implement comprehensive security measures to protect the network from cyber threats. These include firewalls, intrusion detection system, and robust password policies. And the next is network maintenance. Regularly maintain network infrastructure to ensure optimal performance and prevent issues. This includes software updates, hardware upgrades, and routine checks. And the last is disaster recovery. Develop disaster recovery plan that outline procedures for restoring network services in the event of major outage. This plan should include backups, failover, and mechanism community strategies, and that is the ensuring consistent network performance. The next is the network design consideration. Network topology. Choose an appropriate network topology that best suits the organization needs. Common topologies include star, bus, ring, and mesh. And the star topology is a network design where all devices are connected to a central hub or switch. In a star topology, messages are sent to the central hub, which then passes them to the intended destination. This network design is commonly used in computer networks because it is efficient, reliable, and easy to maintain. However, it has some disadvantages, including the cabling. Star topologies require more cabling than other topologies. The next is central hub. If the central hub fails, the entire network will be unusable. And the last is cost. Star topologies can be more expensive than other topologies because of the cost of the connecting devices. And that is the star topology. And the next is the bus topology. It's network topology where all the devices are connected to a single cable, called a bus, that acts as a shared communication medium. The cable allows all the devices to receive the same signal simultaneously. And there are some things to know about bus topology. First is signal travel. The signal travels along the cable like an eye cell, finding the node it's intended, and terminals and number of cables. And the ring topology is a network configuration where devices are connected in a circular pattern forming a closed loop. In this setup, each device is connected to exactly two other devices, allowing data to travel in one direction around the ring. Here are some things to know about ring topology. How it works. Each device in the ring acts as a repeater, regenerating and transmitting the data. And the advantages of the ring topology is provide equal access to all devices on the network and adding additional nodes has very little impact to bandwidth, and that is the advantages of the ring topology. And there's also disadvantages of a ring topology. If any one link inside the ring fails, the network as a whole is impacted. Other devices include adding or removing a node from the network can be difficult. And that is the ring topology. And the last is the mesh topologies. A network configuration where devices are connected directly to the multiple other devices, forming a mesh-like structure. This decentralized design allows data to travel through multiple paths, enhancing redundancy and fault tolerance. And the physical infrastructure, consider the physical layout of the network, including cable routing, device replacement, and environmental factors. And the network segmentation is a segment the network into the logical units to enhance security, performance, and manageability. This can include separating user traffic from critical servers. And the last is the quality of a service, or QoS. Implement QoS mechanism to prioritize specific types of traffic, ensuring that critical applications receive the necessary bandwidth and resources. And that's all. Thank you.